So as we continue with probability, there is some more vocabulary to kind of pick up on. So we see these words like experiments, outcomes, and sample space. So an experiment is a process that produces a result. So an experiment, ones that we're talking about, like one roll of a die or flipping a coin. What's the outcome of flipping a coin one time? What's the outcome of rolling a die one time? That would be it's going to produce a result. Drawing a card or flipping a card over, the outcome. So an outcome is a single result of an experiment. So if I roll a die and get a four, the four itself would be called the actual outcome. So the process is called the experiment, and the result of that experiment is called an outcome. And then the sample space is all the possible outcomes. So if I flip a coin, there's only two outcomes possible, heads and a tails. So the sample space, they're using S here for sample space, is going to be the set of heads or tails. So this is the set notation. So it's going to be the set of all possible outcomes. So when you see that word set, a lot of times you'll see these little braces involved. And what's in that set are the possible outcomes. So that's kind of a formal way of writing it. So if I roll a die, notice that the sample space itself would be the set of 1, 2, 3, 4, 5, 6. Notice before I was just listing. Now this is a formal way of writing that sample space is using the special notation of set notation. So this brings us to question 8. So question 8, we have three fair coins are tossed. The two possible outcomes of a single coin are heads and tails. So the two possible outcomes for a single coin is head or tail. So this says write out the sample space. So notice that since there's, two favorite outcomes, heads or tails, but notice how we're flipping the coin three times. So we have actually three actual experiments there is flipping the experiment itself is flipping the coin three times. So, but then we have the process to go through here. So notice that if I flip it once, I have a choice of a head or a tail. But then we can kind of create a tree diagram. I can flip it again and I can get a head or a tail. If I flip it again, I could get a head or a tail in this one. And then if I flip it a third time, we could get a head or we could get a tail. Or again, we could get a head. Oops, don't need an arrow there, just making it a tree thing. All right, cooperate, cooperate, cooperate. So I could have a head or a tail. So a tree diagram could be a good way to actually generate the sample space. So if I follow across here, I could get a head, and a head. That would be one outcome. I could get a head, a tail, and a tail. So a head and two tails. Or we could get a tail and a head and a head. Or we could get a tail, and a tail. So those would be our four outcomes. That would be our sample space. So the sample space would be the set of, we'd have a head, and a head. We could have a head, a tail, and a tail. We could have a tail, a head, and a head. And we could have a tail, tail, tail. So there's our sample space. Those are our outcomes. So the question says, determine the probability of no heads. Well, if there's no heads, that means we're talking about tail, tail, tail. So there's only one favorable outcome out of four outcomes. So the probability of no heads would be a 1 out of a 4 chance if I write that as a fraction. So determine the probability of exactly one tail. So if we look for exactly one tail, it looks like this would be that tail, head, head. That's the only one I see that has exactly one tail. So there's a 1 and 4 chance there of getting a exactly one tail. So that sample space really helps us out there in a tree diagram, helped us get that. Determine the probability of no more than 2 heads. So no more means you could have 0, 1, or 2 heads. So to determine the probability of no more than, I cannot exceed 2. So I could have 0, 1, or 2 as possibilities. So head, head, head would be, can't use that one because that's got 3 heads. But notice that this one has 1 head, this one has 2 heads, and this one has no heads. So we do have 3 that are favorable outcomes out of 4. So 3 out of 4 would produce that. So notice how again we have to kind of list our favorable outcomes here. So we have 3 favorable outcomes out of 4 outcomes altogether. So to determine the probability of exactly 3 heads, so notice how we do have head, head, head. That's our only one. There's only a 1 in 4 chance of that happening. So notice how doing the tree diagram helped us see the sample space. And once we saw the sample space, then we could generate our probabilities from that sample space.